Hi, and welcome to week four, and we're looking more into capital budgeting applications. So last week it was really about an introduction to capital budgeting principles where we talked about some costs and we did stuff like looking at using two-way tables, one-way tables. We looked at incorporating taxes, so on and so forth. So we're going to do a bit more of a deep dive into capital budgeting, particularly in solving for what projects should we invest in. So that's pretty much the whole point of today's lecture. Okay. So as a result, we have recommended readings, which is section 2.3 of the textbook. So make sure you do read them. And at the end of the day, the lectures are here to go through the principles, to test you, to interact with all of you. And the course text sometimes gives you more insight into these issues than we can cover in the lecture. So the lecture really highlights the most important points with examples. So let's do a bit of refresher. What is capital budgeting? Really, at the end of the day, it's just about evaluating whether we should proceed or not with a certain investment, right? So if you're a finance person, an accountant, the boss tells you we've got 3 projects, what should we dive into, right? So what actually happens is there are different techniques like net present value, internal rate of return, which is basically what we use to determine whether investment is worthwhile to undertake, right? So basically what happens, capital budgeting techniques allow us to objectively select between different types of investments. Okay, these different investments can be mutually exclusive projects or capital raising constraints. So what we mean by capital raising constraints, we don't have that much capital, so we need to use it wisely. So this is a really, really important part of any financier or accountant's job. And we use Excel to help us work all these things out. So this is where we actually use a lot of fundamental financial theory and tools like weighted average cost of capital, like free cash flows, so on and so forth, to actually work out what the right project is to invest in. Okay, so let's look at net present value. So NPV, most of us know what this thing is already. It really is net present value, and net always stands for the fact that we're actually subtracting two things away from each other. It is the present value of future net cash flows minus or subtract the present value of investment costs. So it is present value of net cash flows minus net of investment costs. You can think of it as generally profit minus equals revenue minus cost, but also take into account the time value of money and focusing on cash flows rather than accounting accruals. So what are accounting accruals? Well, basically in accounting, there are things like receivables, but accounts receivables means you might have sold a product or a service, but that cash hasn't hit your account yet. So these cash flows are actual cash flows which enter your bank account, right? So basically, net present value is just profit equals to the revenue minus cost, but incorporating time value of money and focusing on cash flows. And that's pretty much it. That's a good summary of the NPV. So it's a bit of a refresher, okay? The function in Excel for NPV is the NPV of the rate and all the different cash flows, okay? And INV is not considered by Excel as a net present value equation. Okay, so what do we mean, right? So you need to actually separately account for NINV, which is the investment amount, separately. So what happens, we actually use NPV, put in the discount rate, put in all the future cash flows, then we subtract the investment amount. Okay, so basically net present value is just a function for PV and CF. So what happens, we're lots and lots of acronyms here. Okay, so we've used the acronym of NPV and CF and NINV. That's our acronym for present value of net cash flows, and NINV, which is the investment amount. But in Excel, it's just an NPV function. Okay, so another one that we often use is going to be the internal rate of return. So the IRR is really just a discount rate that equates the present value of net cash flows of a project to the present value of NINV. So what it means that it is the discount rate that make sure that the present value of all the future cash flows is equal to the PV, so it equals to 0. So basically, the IRR is the discount rate that makes the NPV equals to 0, which is when present value of net cash flows to the project minus the investment amount equals to 0. Okay, so that's reaffirmed from this formula over here. NPV equals the cash flow 0 plus CF, 1 plus IRR, so on and so forth, and it all equals to 0. Okay, so your first investment amount, CF naught, plus all the positive cash flows coming in, discounted by IRR as a discount rate, it all equates to 0. So IRR can be sort of like the break-even point, okay? The break-even point. So IRR, we actually have used it before. We used it when we calculate the yield to maturity of the bonds, especially when we have all the different cash flows. Okay, we can actually use IRR to work out the yield to maturity. So CF naught is almost always negative value, right? So what this means is that because CF naught is usually the outlay or the initial investments to start the project, okay? So there are times that cash flow naught can be positive, and investments are made during some of the time. It's not just the most relaxed situation, but you might not always find a result. So basically, don't be misled, and we have CF naught here. This is actually a negative investment amount. These are all positive cash flows. Okay, so now we've understood net present value versus IRR. What is the difference? Okay, so net present value, if it's more than 0, more than equals 0, you can accept the project. If it's less than 0, reject it. For the IRR decision rule, if the IRR is more than or equals to the weighted average cost of capital, also known as WACC, you accept the project. If it's less than WACC, you reject the project. So when the IRR is more than WACC, then net present value must be more than 0 because the project return is higher than the cost of capital. Okay? So I just want to make sure all of us know what WACC is. It's the weighted average cost of capital. Okay? Some of you may or may not remember, it's weighted average. So basically it's whether we raised funds from equities or bonds, right? There's a cost of capital, cost of actually raising capital via equities, cost of capital from raising capital via bonds. The amount of money that we raise, whether it's through debt or through equity financing, right, is a weighted average. So just as a quick reminder, I'm going to bring up the weighted average cost of capital formula just to make sure that we're not lost. Okay, so this is weighted average cost of capital. A firm's average after-tax cost of capital from all sources, including stock, bonds, and forms of debt. Average rate that a company expects to pay to finance its asset. Okay, a common way to determine the required rate of return, because it expresses in a single number the return that both bondholders and shareholders demand to provide the company with capital. Okay, so let's look at the formula. This is a brief reminder, and this is the formula. You can see this component is the market value of firm's equity times the cost of equity, which is raised from stock. This is from debt, and basically just the weighted average cost of capital equation. So just a brief reminder, right, to both of you who may have forgotten what it is, and hopefully that rings a bell. But when the IRR is more than WACC, NPV is positive because the project return is higher than the cost of capital. So we proceed. So we can see from this graph over here, the IRR is the point at which it just hits 0. Okay, so let's look at mutually exclusive projects. So what is a mutually exclusive project? It's basically when projects are mutually exclusive, NPV and IR can produce different project rankings. This is really because of there's size and timing problems in IRR, and basically the size and the timing of different cash flows. Okay, so basically what happens from the earlier finance courses, you probably recall that sometimes because IRR has certain issues, net present value is the optimal capital budgeting criteria. So now let's look at exploring a couple of examples so we can actually, work through some of these like different tools out.